Hey everyone, and welcome back to section 4.1. This is the last method for solving systems of linear equations, and this is probably the most standard one, and it's called elimination. So here we have a system of linear equations, and so let's remember an important property about addition. So if A equals B, then A plus C is equal to B plus C. In other words, you can add the same number to both sides of an equation. So what I'm going to do here is take this equation and I'm going to add to it the quantity 2x minus y. Since I'm adding something to one side, I have to add it to the other side. However, we also know that 2x minus y is equal to 0, so I can add that, and it would be the same as adding 2x minus y. And so the net effect is you have basically added the two equations together, giving you 5x, and then y plus negative y gives me 0y. 5x equals 5, and then x is equal to 1. From there, you can use either of the two original equations. So 2 is equal to y, and we get that our solution is 1, 2. So that's basically the method of elimination. So I'm just going to go through and explain what it is that you have to do, what the goals are. So first of all, you want to write both equations in standard form, if they're not already in standard form. And if you have fractions in either of the equations, clear them by multiplying by the appropriate denominator. Then what you want to do is pick a variable that you're trying to eliminate, and you want to make their coefficients opposite to one another. You might need to multiply one or both of the equations by a number to get the coefficients to be opposite. That's totally okay. Once you've gotten there, you just add the equations to eliminate that variable and solve. After you've solved for that one variable, you substitute the solution from the previous step into one of the original equations. Then you can solve for the other variable. Lastly, you want to write your solution as an ordered pair, and of course check your solution. So let's look at another example. All right, here I have a bunch of fractions, which I totally don't want. So I am going to clear them. And what can I do to clear them? Well, so in the first equation, I have 1/3 and 1/2. So I can multiply by 6 on both sides of the equation. And how about the second one? Oh, so I can multiply by 4 because 4 is a multiple of 2. And now we're going to simplify. Of course, we're not going to forget to distribute when we multiply. Okay, so after I do the multiplying, I can simplify my fractions, get rid of them. Okay, so now I don't have any fractions. Next, I have to kind of decide beforehand which of the variables I want to eliminate. It doesn't really matter. Sometimes it might be easy, like in the first example, the coefficients were already opposite, so it was pretty clear. For this one, it doesn't really matter too much. So let's say we're going to eliminate x. The goal now is to get the coefficients, the equations, to be opposite one another. So I need to figure out a common multiple. And between the coefficients 2 and 3, a common multiple of 2 and 3 is 6. Here, I want, let's say, 6x. And here, I want the coefficient to be opposite, so I want negative 6x. So I have to think to myself, what can I multiply both equations by to get the appropriate coefficients? For the top equation, I multiply by 3. For the bottom equation, I'm going to have to multiply by negative 2 to make my x coefficient negative. And now we have what we want because the coefficients of x are opposite, so we can just add these two equations together, which would eliminate the x variable, and then we would have negative 9y plus 8y equals 18 plus negative 20. So we get negative y equals negative 2, or y equals 2. And from there, we can use either of the two equations that we started with, or we can also use these simplified ones. So I'm going to use 2x minus 3y. And I get x equals 6. So 6, 2 is my solution. Let me just check real quick. And everything checks out. So our solution is 6, 2. All right, last example. Here we have 3x plus 4y equals 12, and y equals 3 minus 4x. So first of all, we want to get the equations into standard form, which means we want x and y on the same side of the equation. So in the second equation, I have to add 3/4 x to both sides. And now I have to clear my fractions. There's only one fraction, so I can just multiply the whole second equation by 4. Okay, so both of the equations are now the same. Well, I want to decide which variable I'm eliminating. Let's say I want to eliminate x. To make the coefficients opposite, I gotta multiply, well, I can just multiply the second equation by negative 1. Okay, now if we add them together, Um, oh, well, that's not very helpful. So let's think for a second. Everything canceled out completely when we added. So in other words, that means these two equations represent the same line. They have the same graph. So there's really only one graph, and we know how many solutions one linear equation has, right? Namely, every point on the line. So there's infinitely many solutions. That's because you get something like 0 equals 0. And the other case would be if you end up with something like 0 equals 5, or 0 equals 2, 0 equals something other than 0. If you get an equation that is false no matter what, that means that there are no solutions. Those are kind of the three cases, right? You either get a solution, you get no solution, in which case you'll get something like 0 equals 2, or you have infinitely many solutions and you always get a true statement because you're ending up with something like 0 equals 0. So anyway, that's the third method. I'm going to be mixing and matching probably as we go on, depending on what the situation calls for, but this is kind of the default method. That about wraps it up for section 4.1. Now we're going to be moving on to word problems. So I'm sure you can't wait.